This is section 8.3, part 1 in geometry, talking about trigonometry. Okay, so in the previous sections, we've talked about special right triangles and how to find sides and all those types of things from certain ways, and those were the special triangles. But what happens when your triangles aren't special? They aren't 45, 45, 90, and they aren't 30, 60, 90. You still have a right angle, but what happens if it's 42 and 48 degrees in the other two angles? Well, we're going to be able to find a foolproof way to calculate any amount of side we need, okay, using what we call trigonometry. Now, our objective here is to use the sine, cosine, and tangent ratios to determine the side lengths and angle measures in right triangles. Now, the sine, the cosine, and tangent. What are they? Well, they're what we call the trigonometric ratios. So, if I have either one angle and one side or two sides, I can figure out any angle measure or any side length I want using these ratios. Okay, so remember, a ratio is a fraction. Okay, so as we look at the trigonometric ratios here, the sine, these are things you're going to have to memorize, and I'll have a little saying here in just a little bit for you to go through and kind of memorize so that it'll help you with putting these together. So the sine of the angle, in this case it matters on what angle you're looking at, and we're going to go through all that, but it says the sine of angle A is equal to the length of the hypotenuse, or the length of the leg opposite of angle A over the length of the hypotenuse. In this case, angle A is right here. This is where angle A is, okay? And if I go opposite of angle A, the side opposite angle A is A. And then the hypotenuse in this case, which happens to be C. So it'd be A over C. The cosine. The cosine of angle A is the length of the leg adjacent to angle A and divided by the length of the hypotenuse. So here's angle A. The length adjacent to it is B. It's part of the angle. Okay. And that's divided by the hypotenuse, which is C. Okay? So, and then the last one is the tangent. The tangent of angle A, which in this case, the tangent of angle A here is the length of the leg opposite of angle A. So the opposite of angle A is side A, divided by the leg adjacent to angle A, which is B, which is side B. So A divided by B. Now, these ratios, using these ratios, we can determine any length we need to of a side or the degree of any angle that we need. Okay. Now, the first part that we're going to start off with is I've got this right here, and I want you to write this down in your notes. This is what we call SOHCAHTOA. Okay, and it essentially stands for the SOH, the CAH, and the TOA stand for how to find sine, cosine, and tangent. Okay, so as I look here at the SO part, SOH means that we have the sine equals the opposite divided by the hypotenuse. Sine is opposite divided by hypotenuse. So, SOH. The CA, SOHCAHTOA. CA is CAH, which means that the cosine is equal to the adjacent divided by the hypotenuse. Okay, and then the last one is TOA, which stands for the tangent is equal to the opposite divided by the adjacent. Okay, so SOHCAHTOA is what you're going to hear me say quite a bit as we go through and figure out how, first of all, what the sine goes with, what the cosine goes with, and what the tangent goes with. SOHCAHTOA. Something very important for you to remember as we go through this. Okay, so let's go through some examples now. All right, so it says find the sine of U and the sine of W. Write each answer as a fraction and as a decimal rounded to 4 decimal places. Okay, so we've got to find the sine of angle U and the sine of angle W. Well, let's start here. Angle U. Again, sine is opposite over hypotenuse. So the side opposite of angle U is 16. The side of the hypotenuse is 34. So this is opposite over a hypotenuse. 16 divided by 34. Now, when you type in 16 divided by 34 into your calculator, the decimal is 0.4706, rounded to the nearest tenth, or rounded to the nearest 10,000th in this case, 4 decimal places. Okay? So, that's how you find the sine of angle U. The important part is being able to identify the angle, and then what side do you need? Do you need adjacent, do you need opposite, or do you need hypotenuse? Okay? So, next one. The sine of angle W. Well, as we look here at W, W is right here. The side opposite of W is 30. The hypotenuse is still 34. Remember, the hypotenuse is always opposite of the right angle. And if I divide 30 by 34, this is 0.8824 as my decimal. Okay. All right, so let's go through an example of cosine now. Remember, the cosine is equal to the adjacent over the hypotenuse. So what I want you to do, see if you can figure out the cosine of S and the cosine of R, their ratios, and calculate them to their decimals, and then hit pause and see if you get them correct. Okay, now that you've hit pause, let's take a look at the cosine of S. S is right here. That's where angle S is. The side adjacent to it is, in this case, 45. And the hypotenuse is 53. So when I divide those out, I get 0.8491. Okay. Then, if I look at angle R is right here. The side adjacent to angle R is 28. And the hypotenuse is 53. And when I divide those out on my calculator, I get 0.5283. Okay. So now I've been able to calculate the sine and the cosine. Okay, so now let's take a look at the tangent. In this case, the tangent we want is opposite over adjacent. So we want the tangent of angle S and the tangent of angle R. Again, pause the video, see if you can come up with these two decimals, and then hit play. Okay, now that you're back, you figured this out. Let's start here. Let's see if you get it right. Angle S is here. We want the side opposite of angle S, which is 60. And adjacent to angle S, which in this case, adjacent to angle S, is 25. And when I divide those out, you get exactly 2.4. Now, if I go through and I calculate the tangent of angle R, here's angle R. Opposite of angle R is 25. And adjacent to angle R is 60. And when I divide those guys out, I get 0.417 or 0.4167. Now, this concludes the work for 8.3 Part 1. Don't forget to complete your WSQ. And also, don't forget to go back and study SOHCAHTOA. When you come to class tomorrow, understand and know what SOHCAHTOA stands for. Okay? That's going to be an important part on what we're doing here. Okay, this concludes sections 8.3, Part 1. Again, don't forget to complete your WSQ.